Hello and welcome to yet another video. And today we have an Asus Prime X570 Pro. I don't really know what is wrong with this board. It's a beautiful board. I've fixed one of these before. I really like these. They have really good I/O, and yeah, I just really like this platform. And I've had this. I think I fixed two of these before. One had damage under the M.2, I think somewhere. One had damage right here. There was a 1.5 linear regulator missing from the SIO. And yeah, excuse my voice, I'm a little bit sick. Sitting at home since quite a few days, but I got really tired of not doing anything, laying in bed. Now I decided let's go and do something useful and make some content and get some board fixed. So yeah, if I sound sick, that's because I caught the flu. But yeah, luckily getting better. And let's see what we can do with this motherboard today. So we have the 2200G in here now. And let's see for the passive power consumption. We have lights turned on, 160. I think that's normal with standby and having LED lights. So let's see, does this have a power switch? Yeah, this has a power switch right there. Let's see how it reacts. And we're stuck on DRAM. 2.5 amps. Okay. Let's just plug in some RAM into here. Let's see if it's still going to be stuck on DRAM. Because this DRAM LED isn't an actual DRAM LED as far as I know. 2.8 amps. Like, the power consumption looks really good, but it's stuck on a DRAM LED. The very important thing about Asus boards with their LEDs is that they have the DRAM LED in the highest slot, in the first slot that turns on, and then CPU. But the initialization of a board works the other way around. It's first CPU and then DRAM. And I've had multiple times people come up to me and say that I have a problem with the DRAM LED on an Asus board, where they actually had a CPU problem and not a DRAM problem. They tried to do everything related to the DRAM, but they didn't have a DRAM problem at the end at all. So this is very confusing for Asus. Had to find this out myself. But yeah, first thing I always suspect when I get actually this high of power consumption, like 2.8 amps, which really looks like it wants to start up, but we're still stuck on CPU, is that there is some damage around the SIO or around the socket, that there's some resistor missing or something like that, and some small signal isn't reaching the actual SIO or maybe the hub. So let's have a look around the SIO first with our microscope, and then we also might have a look around the CPU socket. And now looking at the SIO, let's see what we can find here. This is just dirt. Let me get tweezers. Let's see, can we find anything knocked off or partially damaged. So far so good. And this area looks like it got chipped or something similar. If you have a look, you can see this resistor might have gotten chipped right there. Then this resistor. Then whatever was here. But I don't think there's a knocked off component here. We also have some damage here and there. Let's see. Also, this capacitor got scratched and this regulator also. But none of this looks to the point where it wouldn't work anymore, to be honest. And these traces got dented in. But I don't think that they're damaged in a way where they wouldn't have connection anymore. So we will be checking other stuff first. We might come back into check the value here of these resistors, but so far I don't think that this is our problem area. So up next, let's have a look close to our BIOS chip, which is right here. Let's see, these resistors often get knocked off, or like the traces that go out sometimes have damage, but this time they look to be fine. Yep, can't see any damage there. Then let's go closer to the CPU socket. So we're starting below the CPU socket with our visual inspection right here. And this is just some thermal paste stuck in between some resistors. Oh, this seems interesting. Can't really tell you what this is. Like, this looks like when oil gets into water. This is what this looks like. Interesting. Or when stuff gets really hot, it sometimes looks like that. This is just some dirt here. Nothing special. Definitely a dirty board. But no obvious damage as of yet. So now we are at the top of this socket. Top left corner. Still looking fine though. Let's see. This is the top right where often the PWM controller is sitting, but I don't think it does this time. But there is some logic circuitry here. But looks fine here as well. And now we are close to the M.2 where the cover is actually on. And let's see. I've had damage in this area before because people need to get under here to fit an M.2 drive into here. And this area is very densely packed, as you can see, with a lot of very small SMDs that can be knocked off very quickly and easily. So let's have a look if anything here is missing. And currently we are under the TPU chip of Asus boards. This is very often responsible for holding boards in a reset state, where we sadly still have very little information how these TPU chips work. But still, nothing that I could find that was knocked off or damaged. Not obviously, at least. So, next one where I would be going is the backside of the board. So, let's do that. So, we're currently at the top left of the board, where the CPU 8-pin connector is. So, let's see if we can find any damage here. Definitely quite some components fitted. Also a lot are not fitted, but seems to be it. And nothing damaged here. Let me search for more areas where there are components. A few capacitors here on the back. And this one capacitor, or these two, look like they have gotten some abuse. Like these two. Don't think that would cause a problem, but still should keep those in mind. And now behind the PCH area, but I feel like there's only capacitors. Oh no, not only capacitors. but nothing knocked off. All looks good. So, contrary to my expectation, there's no physical damage on this board. I want to see if PCIe reset is actually stuck on this board or not. So, let's see. We can now see the 3 VSB, and let's switch it on. And yeah, like I thought, PCIe reset is permanently... Oh, is it not? Is it not stuck? Why are we booting now? What is this? What? It's on VGA now. Huh? I am confused. What is happening right here? It was stuck before. I didn't do anything to it. So let's see that again. Why did it all of a sudden boot? Let's see now. DRAM, CPU, yeah, it just continues now. I didn't even reseat this RAM. I did nothing. Do we get a post screen? It's on VGA and there's a post screen. And it is garbled like that because of UEFI BIOS. And me not being able to capture that properly. Yeah, you can see this is garbled BIOS screen. But it is there. It is recognizing. What is this? Why is it working? I am so confused. Let's put some more RAM into here and see. So let's see if it boots up with all of the RAM populated. I would expect it to take a little bit longer, but yeah, we have such high power consumption. Like 3.9 amps, that is definitely boot up. And you can see by the boot LEDs, I really don't get why it wasn't... Like, this board definitely shows signs of damage. Like, definitely some parts might have been physical damage, but nothing to the point of being knocked off or broken. But I didn't do anything while looking at it. And it was definitely stuck on a DRAM, on the CPU LED, or like the what Asus calls the DRAM LED. Very weird. The only thing I did was to take off the M.2 shield. But I don't think that that would have been able to like short something or touch anything that would prevent our board from booting up. So let's try to put an M.2 into here. And yeah, and see if this does anything. So I've put the M.2 shield back on, and let's see. And I have the M.2 in here, but yeah, it just boots. The current just shows that it works. This is so weird. I was about to look if PCIe reset is stuck, and also try to reset the BIOS then to see if that might help, but the board just works. And all the RAM is being recognized and it boots. Let's see if it goes into Windows. So, the board turned on without any problems. Ethernet is working, USB is being recognized. I'm going to run some stress tests, but it seems fine. But there's one more thing that we need to repair on this board that I've just found while trying to build this board up. So, the only problem with this board is this PCIe latch right here. So, the main latch is broken or is missing, but the slot itself looks quite intact. So what we are going to do, I will probably get some donor board to see if I have one that has a similar flap like this one that we can fit into there. So I found this ASRock Fatality board that has these ones. These look kind of similar, just a little bit different color, but I think this should be fine. So we will be trying to take this one out and transplant into there. Now under the microscope, these things are actually only held in by these little white pillars that you see sticking out to the top and the bottom. All what they are recessed into the plastic to hold them in, to make this mechanism. So this is only physically held in. There is a way to take this out without damaging the slot, but we could be damaging also the slot because this is a donor board that I don't need anymore. But let's see if I can pry this open and take it out. So what you want to do is to pry these walls out, and I always use a flathead for that. And then we want to be able to get enough leeway to lift it out so that it comes out of the recess. And I might just need a bigger screwdriver to pry this open, or I might even want to get it vertically into here like this. And let's see if we can now remove it. As you can see, this is a lot of stress for the socket, so it isn't easy to do. Let's see. This still doesn't work like that. Let's see if I can. I've done this once or twice before, but all of the times were quite stressful for the board. Let's see, can I pry it maybe open and then with the other screwdriver try to take it out? So let's try to pry this open. So the big problem is that it is also attached on these sides right here. So you're pressing also against it at the same time. Let's see if we can maybe lift out one of these sides first. Like if I press down into this one, press it down there, and see if we can lift it out on one side first. But I don't think I can. Let's see if we go under that. Oh yeah, that just popped out. Wow, didn't expect that. And I don't think I've ruined it too much. As you can see, the most important bits are these two recesses down there. And let's see if these now fit into our Asus board. Now this is our Asus board. And let's see if this one just drops down into here and actually sits in there or not. So it seems to be a little bit tight. Let's see if we can get it in here still. But it doesn't fit. So this one is too big for that. These slots here. So that won't work. I might need to find a different one. So looking around, I found this. This is a Prime Z390 board that I have. That has a dead PCH. It has two PCIe slots. So we will be taking the latch of the lower one. So let's hope that this one also goes out easy. Yeah, this just pries out very easily like that. And let's hope that this one now fits better into the bigger Asus board. So now back on our on our X570 Pro. Let's see how well this latch now fits into here. So it seems to somewhat go in, but it doesn't seem to sit. Oh, now now I got it. Very, very nice. So just pushing it just needed to be pushed in a little bit further in. Let me show you that in the overview. And there we are. Almost not noticeable that this isn't the original one that was in here. It now opens and closes properly. Let's put a graphics card into here. And the latches also closes, and the GPU can't be pulled out anymore. And pulling it down, it also ejects. That is very nice. So it really isn't that difficult. So when I saw people do this, I always saw them pry between the slots and try to when they take a screwdriver, they always try to like open up the slot a little bit more and then pull it out. But just opening up and going from the bottom in just worked so much better the 2 times that I now did it. And yeah, really happy because this was the only thing that was really damaged or missing with this board. And now this board can easily be passed on with completely working in good condition. And yeah, really happy for that. Really don't know how this repair came to be because I got this board as defective. Like, the description did say nothing else but selling my defective X570 Pro. And I didn't really bother to ask because I don't really care what the customer has to say. Not the customer, but like the previous owner has to say anyways, because most of the time they're lying anyways or don't know what they're talking about. But this time I'm really confused about what is wrong with this board, because I've tested pretty much what you need to test: the M.2, the USB, all of the RAM, the PCIe, everything just works fine. So yeah, I guess sometimes you just get lucky. And this time I was hopefully at least able to teach you on these PCIe latches, how these work, and that these can be very easily replaced without replacing the whole slot. If the actual It can be that the actual slot is damaged and this won't hold anymore, then you will have to replace the slot. But many times just this latch itself is broken, and it can be easily replaced with another one. And you wouldn't even really notice that this isn't from this board if you didn't know what was here originally. So yeah, thank you very much for watching. This was Mainboard Medic. All of my tools are linked in the video description. Hope you subscribe that you don't miss any further of my videos. Thank you very much for watching, and goodbye.